Everyone, we're going to go over a nonlinear regression today using JASP. So let me share my data with you. We're going to be looking at the crisis stabilization scale. That's a scale I developed, and it looks at adolescent coping for adolescents in crisis, usually admitted to psychiatric hospitalization. And it has two scales on it, a coping scale and a commitment to follow-up scale. And we're going to be looking at the relationship between coping and behavioral symptoms. So that as coping, what would we'd hypothesize is a negative relationship, that as coping increases, behavioral problems or behavioral symptoms would decrease. And in doing this, I like to standardize my variables first. And so I'm going to create a z-score or a z-coping variable in JASP by clicking here and typing in z-coping and creating that variable here by looking at my coping variable and subtracting it by the mean of coping divided by the standard deviation of coping. And so that would be right here. And now I'll click compute column, and now I've got a z coping variable. So I've standardized this variable here. And one of the things that we can do with JASP is that we can look at the relationship between our predictor variable, z coping, and behavioral symptoms. And when I plot this, I can ask for a scatter plot. And usually, we ask for a linear plot, which forces the model on a linear relationship. But I can also ask for a smooth model, which looks at the relationship based on the data. And as you can see, when not forced into a linear relationship, there is a curve to this data, a rather pronounced curve. And I might conclude then that this data are nonlinear, that this is a curvilinear. So, if I didn't have a regression line, here's what my data would look like. And it's really ambiguous. And so I like to add a smooth regression line to see what the data are doing. And you can say, oh, wow, there really is a curve to this. And so let's run this as both a linear regression and as a nonlinear regression and see what happens. And so here what we can do is if I want to just look at the linear relationship between coping and behavioral symptoms, I might look at the correlation between these variables first and hit z coping and behavioral. And we can see that there is indeed a negative relationship, but it's only minus. It's kind of small. And so when we run the regression here, go to regression, linear regression, click on my criterion variable of behavioral and my predictor variable. We can see that I do have a statistically significant relationship. I'm accounting for 8.3% of the variance in the model. But watch what happens when we account for a nonlinear relationship. And we could see right back here that there seems to be at least one inflection point. And so what I'm going to do is, in order to create an inflection point, we square our predictor variable. And so once again, I'm going to go to here. I'm going to type in z coping 2, saying I'm squaring the variable, and that's going to be z coping times z coping. And so now I've squared this variable. And now watch what would I do here. I go to my I'll go to my linear regression, and we put in z coping and behavioral, but now I'm going to put in z coping 2, and I'm going to ask that the first time, Z coping actually become part of the null model. And the let's look at the R squared change here. And now watch what happens. I've gone from 8.3% of the variance in the model to 16.6% of the variance in the model. Notice that my model is still statistically significant. I've had a significant change in my R squared, and I'm now accounting for 16% of the variance of the model. So this curve, accounting for this curve and not forcing it into a linear relationship makes a difference. So that is how we can perform a linear regression and see the change that occurs when our model is indeed curvilinear. Now, sometimes there's more than one inflection point. Let me give you another example. Let's say I wanted to look at the relationship between coping, and I got a measure here on adolescent suicidality. So I'm going to put that here. And once again, type in plots and ask for scatter plots. There we go. And look at this. Notice that there's more than one inflection. There seems to be at least two inflection points going on. And so this won't be accounted for in a in what's called a quadratic regression, where we just squared the predictor. We're going to have to cube the predictor to account for at least another inflection point. And so what I do here is I'm going to create another variable now. I'm going to call it Z coping 3. And create column here. And that's going to simply be Z coping times, Z coping times Z coping. So, and it looks like I could have just clicked here and made an exponent and then put a 3 there. That would have been another way to do that. So, and then I compute the column, and so now I've cubed it. And now watch what happens here now. I go to linear regression, and once again, well, now I'm going to put in my criterion variable as suicidality. And I'm going to put in Z coping and Z coping 2, and make as part of my model, make Z coping as part of the, and so we can see here that with Z coping as part of the null model, that the null model was not significant. The quadratic model is not significant, but let's see what happens when we add the cubic model to it. Oh, and we want to account for we want to account for any R squared change as well. There we go. And now look here. Look what happens. Is okay. It's marginally not significant, but we have accounted for 6.3% of the variance in the model. And so we do see a change happening, a significant change happening between the initial model and the cubic model. And so here we can see how when we have 2 inflection points, we can run a cubic regression to account for the relationship. And you know how we end up spotting this is through our through our scatter plots by running the smooth regression and not forcing it into a linear regression. So that concludes our tutorial on nonlinear regression using JASP. So let me know if you have any questions.